We've established that the workflow serves as the main orchestration tool. We chain heterogeneous processes in a sequence in line with the objective, and they execute in that order. Inside any workflow, we find embedded functions to fine-tune both sequencing and scheduling. In the baseline configuration of an object, anything you add always applies, irrespective of use. If you add scripting to a job and use that job in multiple workflows, the scripting always executes. Other configuration elements are specific to the context of the workflow. These are task properties. An object used in a workflow becomes a workflow task. It has properties to enhance the workflow's capabilities. Calendar conditions enable the isolation of a task with scheduling that deviates from the main workflows. We use calendar conditions to handle requirements like the insertion of a once-a-year end-of-fiscal process to a daily sales data workflow, for example. Conventional workflows rely on advanced conditioning capabilities to make an execution dependent on the status of an upstream job, values stored in a variable, min and max runtimes, and a lot more. Resulting actions, meaning the behavior assumed by the dependent job, can also vary: skip task, abandon task, or block the workflow altogether. Finally, workflows can be interactive. We can create and assign prompt sets, which are simple UIs to capture user inputs. These inputs are stored in variables: a dataset type, a number of records, some dates, yes or no prompts, list selections, and more. You open a workflow, right-click a task, and select Properties. The Properties bar appears below the workflow. Categories include General, Calendar, Variables and Prompt Sets, Conditions, and Runtime. Active presents an on-off switch that disables the task at workflow runtime. This is used a lot for testing when you're analyzing a workflow but want to bypass a time-consuming job or one that targets live data. The task is simply skipped. The breakpoint is one of the features presented by the use case. An enabled breakpoint suspends the task in the workflow at runtime. The breakpoint needs to be manually released. An operator accesses the workflow monitor and deletes the breakpoints. The workflow can then proceed. The enable rollback switch enables any rollback function that exists in the core object definition. If the process fails in the workflow, an operator can right-click on the task in the monitor and execute a rollback. Whatever you defined executes as a result. Finally, request user input suspends the workflow by withholding execution of the task until an input is provided by an operator in workflow monitor. The purpose of calendar conditions is to isolate one or more tasks so as to apply a schedule that diverges from the overall workflow. This is a purely scheduling feature. We do this with a calendar object. Common scenarios are found in financial processing when you need to insert a yearly end-of-fiscal process to a daily workflow. You design a calendar object, which you might call last day fiscal, and then apply the calendar condition to the task. We demo this in another module. We withhold execution of a task in daily workflow on weekends and holidays, say due to shift constraints in the ops team. The three types of conditions are all, means all conditions must be met for the task to execute. If New Year's Eve is a Sunday, then the task executes, which in our case makes no sense. No condition means the task only execute on days not designated by the calendar. For us, this is much better. Finally, one executes on days designated by either event in the calendar, either a weekend or a holiday. You may occasionally still hear the word keyword. Keyword is an older term. Keywords and events are the same thing. Variables and prompt sets assigned to individual objects like jobs are shown in their respective tabs. This does not apply to the use case. We prompt users interactively for inputs. However, that prompt sets and variable combo is assigned to the workflow in its entirety, not the individual job. And so when the workflow activates, users are prompted immediately. Captured values apply to all tasks in the workflow. Execution conditions prevent task execution either before or after it's been submitted for processing until the condition is satisfied. Preconditions look at the conditions first and then submit when the condition is met. If they're met, then the job can physically execute against the agent. Post-executions allow task submission, but withholds actual execution until the condition is met. The task is acknowledged by the processing engine, but does not actually execute against the agents. Common conditions include checking the value stored in a variable, evaluating the status of a connection, or checking for the presence of a file or a live process. We also set the resulting behavior, say skip the task, block the workflow, or set a variable value. Final actions are typically used to set the final status of a workflow, especially if conditions fail to resolve over time. You set a condition and either a number of condition checks or a time period in minutes. If the conditions are never satisfied, the final status of the task is set, say skip, block, or append. This is to prevent workflows from being permanently hung. Finally, you can set minimum and maximum runtime conditions. Automic Automation runs continuous runtime average calculations based on sample data. Averages can then set the relative status of a task. Imagine the following scenario. Based on, say, 5,000 executions, Automic has determined that a task takes 2 hours on average. You can set a runtime on this task. If the current execution took less than an hour, or more than 3 hours to complete, then we'll assume that there's a problem that needs to be addressed. You could also use a fixed value, say 1 or 3 hours.